Hello, everyone. Thank you for taking this time. I know it's been a long day for many of you guys, and giving us your brain for this period of time. Really appreciate you being here. So, sorry. OK. To start off with this presentation, component contributed architecture, democratizing platform engineering. It's a mouthful. We put it there on purpose. I hope somebody sticks to it. But before we start anything, can we get a quick show of hand of how many people are building internal development platforms on Kubernetes? Just like I thought. Who isn't? Exactly as we. OK. So we're starting with a little bit of introduction. My name is Anoop. I work as a Vice President of Engineering for Guidewire Software. If you don't know what Guidewire is, think insurance. Most likely, your policies are done by an insurer provider who potentially uses our software. And sorry, California guys, we are not the reason for the price increases. And I have with me Jerome.
So hi, everyone. So I'm Jerome. I'm a chief architect. I'm working for Anoop. So we are building the platform for Guidewire that is used by our developer, but also by our insurer. And we will go through this journey through different generation evolution with. Yeah.
So setting the scene on what Guidewire does, we provide a software platform, and on top of that, we also provide a runtime platform for our customers. We have some of our customers right here sitting next to us, couple points there. Glad to see you guys. But it is all built on Kubernetes, and we are present in all these regions. We have our clusters across these 140 customers, 140 plus customers. And you might be thinking, oh, that's nothing. We talk about thousands of microservices. 140 customers don't seem like anything. But trust me, each one of these are huge monoliths. And we run the entire enchilada from monoliths to microservices to functions as a service. And insurance companies, we are highly regulated. There's a lot of compliance demands on us as a provider as well, in addition to the performance requirements for these systems, right? We run petabyte scale data lakes. But today, we're going to focus majorly on how our Kubernetes and workload platforms work. And we've been building the platform since 2018. And I've worked in prior companies before, so it's been a decade of building platforms. One thing that has always hit us is, everybody thinks that anything that has to do with infrastructure has to be the platform. How many of you guys actually have teams building applications coming to the platform engineers to say, hey, I want this new AWS or GCP service, and get it done, make it available for us? How many of that comes to the platform engineering teams? Awesome. This talk is for you guys. And we've faced the same issues because our backlogs are a mile long. And having to accept any new service means, A, we have to get the expertise. B, we have to be able to support it. And so we then started thinking somewhere around 2022 about why can't we invert this entire process? Why does platform engineering have to know about every single cloud resource and service out there? What if we democratize that entire model in such a way that an application team, for example, who knows a lot about OpenSearch, if we give them a guardrail around, this is how you could maintain that component yourself, but also provide a good set of rules and definitions such that they can get something out soon. We don't want them to become platform engineers. We want to be able to gate them, not stop them, and get to a point where they can actually provide value for their app teams. So that is essentially where we started. And the four major pillars for us in terms of how we see ourselves as platform engineers is how do we provide ease of access to these four pillars? And I'll be honest with you, not all four pillars, even within Guidewire, are at the same level of maturity. And what we strive to get is at a high level of independence, at the same time a high level of secured and sandbox environments through which these application teams could work themselves out. And like I already mentioned, as platform, everything, including kitchen sink, is thrown at us, right? I'm pretty sure IAM policies, fine-grained auth, secure software, supply chains, CI/CD, and how do we make sense of it in such a way that the platform engineering team can be highly collaborative and at the same time not the source of, in a way, delays for the app teams to do what they need to do. So primarily, can we agree to the premise that the platform engineering teams can't know everything? Or the fact that if you think you are going to maintain and run all the AWS services or GCP services in your organization, let me tell you, we have deeper scars trying to think we could be the superheroes, but you know what? It's better still you create other superheroes. Application teams, this is a real need, right? It's not the infrastructure that brings the money to the companies unless infrastructure is your product. In most of the cases, it's the application teams and their velocity and at which they can produce value for the companies that actually makes sense. So how do we streamline the process in such a way that they can go faster? A raise of hands, how many of you maintain all the services that platform engineering teams provide in Confluence or some documentation? OK, how soon does it get stale? All right, so these are all the problems we faced as well, in the sense that we'd say we support Aurora RDS, we'd say DynamoDB version X or RDS version Y, and you know what? 2 weeks later, the teams produce a new version through Terraform or modules or whatever, and the consumer doesn't know. And it's an imperative that we need to identify that the app teams need that knowledge now, and they need to be able to get the right knowledge from the clusters. Yeah. The other aspect is about RBACs. We have two extremes within Kubernetes. Either you are a cluster admin or you are relegated to the namespace that you're working on. So how do we measure in between? And how can we get to a point where we can use productive security sandboxes for the teams to be able to go ahead? So in 2021, we started looking at tools outside, and we came across a spec called Open Application Model. And as part of that discovery, we were able to identify an implementation called KubeVela for the same things that we were thinking around the same ways. How do platform engineers give solutions to the customers and provide guardrails around it? How do we package them into boxes? And those boxes are very visible and can be used by the developers. So with that, I'm going to hand off to my partner, Jerome, who's an expert in KubeVela.
Hey, everyone. So yeah, we have 3 demos. So we just have 2 slides to go through. Much better. So I was just saying, yeah, we have a few slides to go through to kind of define some terms. And after we have 3 demos that we want to cover. All of that is also available on GitHub. Everything I present will be available on GitHub. At the end, I will provide the link so you can download all of that, play with that, open issues, and so on and so forth. So what is KubeVela? If you look at this picture on the left, you see the CI. So yes, your application developer or microservices developers, they still need to build a business application. They still need to use CI for that. And at the end, they create an image for it. What KubeVela is what is coming just after that. So the developer before, when they were doing that, it was done. They were handing over to ops. But now, the developers, they are pushing up to production. And for that, what we are saying to the developer, because you're pushing all of that to production, you have to become an expert into observability. You have to become an expert into HA. You have to become an expert into DR. You have to become an expert, etc. So we call that shift left. We say we shift left to the developer, but we just overload the developers, and you cannot have a developer being really an expert into everything. And this is where KubeVela in the middle is coming, because what you have is you have the expert which are building components that the developer is using to compose the application. So then the developer is just using the high-level abstraction on top of this component to create an application that is cloud-native ready, that can be deployed into production, that is composed with some, of course, runtime, database service, messaging services, but also NFR, meaning everything related to HA, everything related to DR, and everything for ops, because yes, they push up to ops, but fortunately there is level 1 support, which is also observing. So this is where they can also declaratively declare some observability to it. And then guess what, with this high level just being declarative, everybody does it the same way. So then into Guidewire, then an operator do not see 50 flavors of microservices. They see one flavor of microservices, which is easy to operate, easy to maintain, easy to deploy. And we are doing that like we do when everything we do into our software. We are creating an experience API or high-level API for doing that in all this domain. So this is what KubeVela is with all these components. In addition to that, it enables you to deploy not only to single cloud, but to multiple cloud. So yeah, so again, I'm kind of a little bit repeating, but so the developer, when they were doing Kubernetes, they needed to know, okay, I need to create an HPA, I need to create PDB, I need to create my governance, and have my specific quota here, I need to take care of my costs and everything, and then, oh, now this Kubernetes resources is obsolete, I need also to upgrade it from a version perspective. And we asked them, say, you need to deploy to prod, but there was no single way for them to describe the topology of the application. We had an internal developer platform where we were generating some CD framework. We're using TeamCity, so they needed to know Kotlin on TeamCity. We were generating some Kubernetes, but they still need to patch this Kubernetes into that. And then they needed also to orchestrate a bunch of tests. So too much technology was exposed to the developer. Even if you try to build an abstraction, at the end is a lot of things to deal with. And then the advantage of KubeVela, it's a unification on all of that, a single technology and really an abstraction on top of it. And really decoupling the application topology from its deployment. So a few concepts before I go to the first demo. So the first one is, of course, there is an application. So this is a top-level CRDs into Kubernetes. What developers are doing, they are developing application or microservices. An application is made of component. So this is a runtime component, your backend. And the backend is using some other component, like they are using storage components, they are using messaging component. This is kind of the business side of it. But you also need to describe kind of the NFR related to it. So this is where the traits are coming. So the traits for one component, they are describing some specific operation aspect of it. So I wanted to scale. So this is where my HPA is coming. This is where my monitoring and so on and so forth. So I'm associating that with a specific component. Here I'm giving an example of a runtime component. But if it's a storage component, an example of a trait is I can say, oh, I need to encrypt this specific storage. And the good thing is I need to version. And then these traits, you can override them also into different topology. So if I am in development, probably I don't need to have a lot of, I don't need to scale. So I just have one pod for it. And if I am in development, I probably don't need to version my database and make it HA and DR. I just do that into staging. So all of that you specify into this place and you can override. So this is where the policy are coming from, where you are really describing rules at the application levels. And the workflow is really how you're orchestrating that. And the add-on is how you are installing third party. I think I spoke enough now. I will go a little bit to a demo. And so this is demo, I recorded it. And why I recorded it, because you will see I go through a lot of different kind of screen. And it has been easier, but it's available again on GitHub. So here I'm comparing on the left really the imperative aspect of it. So I kind of cover it already. So for delivery, you need a CD. Here I put Dagger, because I run it locally, even if we use TeamCity in reality. Runtime deployment is manifest, and cloud provisioning was Terraform. So it was a lot of file, and for each application, it was 8 different files, and the developer needed to be fluent into CD configuration, so Kotlin for TeamCity, they needed to know Kubernetes, they needed to know Terraform. Versus with KubeVela, it's all KubeVela, it's just one single YAML, but really also an abstraction, an experience kind of API on YAML. So it's not like a complex deep Kubernetes kind of YAML with a lot of patching and so on and so forth. It's something pretty straightforward to understand. And you will see that just right now as it goes. Oh, I need to remove this. I'll move it somewhere else. So on the declarative, so as I said, it's just a bunch of files. So again, this is available on GitHub. So you can see the Dagger file, you can see the Kubernetes file. Versus here, what you have is just a KubeVela application. So the KubeVela application here, you see the runtime, which is the web services. So you are very familiar with that. So you are describing a backend runtime. You need to describe an image, describe environment variable, different volume, and liveness readiness probe. And then this is a trait. So this is like the NFR or operation aspect of it. So this is where we have HPA that is defined, pod security context, and limit. And if you see, there is just what you need. There is a lot of boilerplate code that you need to put when you just do that at the Kubernetes level. And here, this is a policies where we are saying we will deploy to dev, we'll deploy to staging, we will deploy to prod. And as we do that, we will also override some parameter. So in dev, we want a single pod. In staging, we want 2. And then in production, we want 3. So here, you can see this is a cluster. There is nothing deployed. You just have Crossplane, KubeVela. And here, this is a KubeVela API, the Vela UX. You can see there is nothing here that is deployed. We will create some object into S3. So right now, you just see 2 S3 buckets. And we have a third one. So here, build the image. And then the first phase is preparing the deployment topology. So I said there is a dev, so staging on the production. And then it's deploying the application. So here, what you can see is that the application has been deployed. It's composed of a backend, but it's also composed of a bucket. And all of that is provision as we, so here this is more logical view. Here, before this was the complete resource view of it. So the logical is just the image on your backend. Here you can see that now the bucket has been created, and as part of the deployment of the application, there is also a set of tests that are run. So not only the application is deployed, but also there is a post request and a get request that are called here so you saw from the workflow that there was different steps. So here I'm describing as part of the workflow step. First, there is a post message where I'm creating a product. And then immediately after that, I am getting this product. And I'm passing parameter from one stage to the other. And so here I could verify that I've deployed to development, and in fact that my application is ready. So then it moved to the next stage, which will be staging. And then here we are doing the same thing on staging. We will push to staging. We will also create a product, so just to make sure that the application is ready. And so, but as you can see right now, we were in a stage in the workflow where we said, before going to staging, I want a manual approval. And so here we approve it, and so now it's deploying to the staging environment, and you can see that the S3 image is ready because I'm reusing the same, so the provisioning was really fast. But here you can see there are two different pods because I'm in staging, and I say by HPA was 2 as a minimum. So in dev, I have a single pod, but in staging, I have 2. And so here, if you look at the Kubernetes view of it, you can see that there are kind of two staging instances in staging and dev. But then what's happening? Prod is deploying. Why it's not waiting? Why is the workflow continue? And why the workflow is continuing? Because you can stop a workflow and wait for manual approval, or you can have an automatic approval after some time. And here it was a 1 minute approval after some time. So it automatically deploy it. And as you can see, there are now 3 different pods, because for prod, I wanted to scale higher. So the minimum set of pods is 3. And if I have 3 zones, I can have also my topology to make sure they are deployed across 3 zones. And this is kind of how I will enable my HA, for example. And then at the end, I did a lot of things here. And I just do one thing. I just do a delete command. And the delete command will just wipe up everything. I don't have to clean up my CD. I don't have to clean up my cloud. I don't have to clean up my Kubernetes. It does all of it for me. Like it created all of it, it also deletes all of it. So it's a single application YAML where I have described all of that. So from a developer perspective, this is a single place where they can describe all of that. And of course, we have internal developer platforms where we create a template already for that. So into the platform, we have different API for different users. We have CLIs. We have UI with Internet Developer Platform, but we are also working on conversational. Everybody has to do that this day. We need to also have a UI interface on it. All right, so this was a demo.
So I don't know how many of you guys realize in that single YAML, there was an S3 component that was like 4 lines. And you could have n number of things after that, like database, SQS.
We have only 8 minutes.
Let's move fast.
So, yeah, should I take it over? Everything?
Yeah,
OK. So this is a view of the OAM application model. So it's another view. So you see the complexity on one side and the simplicity on the other side. But let's go to the mid of it, which is really the contributor model. So as Anoop was saying into the introduction, why we do the contribution model is because in the platform, we are not expert in everything. And also because we don't have an infinite bandwidth. We cannot do everything. So we wanted to enable people to contribute component. And we speak about example like it could be cloud component. But some other components are also observability component. We have some people who are expert into our Datadog stack. So they are the people who can really create this component for Datadog. So then every microservices just declaratively create a dashboard, create some metrics, and all of them are the same. So this is so it's not only about cloud resources. It's about any kind of third party. And we leverage for that the provider that Crossplane exposed to us for doing that. So what it means is that we can create a bunch of modular components. So the contributor, they create these components. They are the experts, they maintaining, they provide support. So by delegating to them, not only they implement it, but you also provide the expert with them. So it's a shared responsibility model. I'm kind of repeating what it is. So as you are the expert, you kind of define the experience API with it. So really the contracts, the default. Yeah, what is important, if you look at Crossplane, they will describe all the possible options that you can use to configure Dynamo table and so on and so forth. But we have an opinionated platform. So no, we just expose what we need. This is a sensible default and simplifying the developer experience. Technical, so you know the product better. You can define the governance with the limits, the versions, the testing. And you also make sure that operation team has everything for that. So you are building the automation, the training, and the first level support of it. As a platform, you got it. We provide kind of the foundation for that. I think I cover all of it. I will go fast because I think I want to go to the demo. It's more interesting. So the demo, this one is live. So here I have just a simple example. Again, it's available on GitHub. I'm describing. First step, you describe your parameters. So here I just want a table name and hash key. And I go here. I create it, I deploy it. So it's creating the component. Then now I want to map this specific parameter to a technical implementation. So how this specific interface is implemented. So I create a composition. And it's deploying it, so it's giving me the noise. I don't know if you hear it. And then I want to test it. And so here I'm creating a simple composite that is instantiating this application. It's creating it. And then now that I have that, I can create my application component on top of it, so which is really kind of defining the developer API for it. So here I'm describing some more information about my status, so I can describe some custom status, return some specific information. So the output here will be the ARN, so that it means you can create a database and then pass it to your web services, so you can pass parameter from one step to another. So I create this component here, and then finally I'm creating my application with it.
So remember, the first four are something that you do probably once or twice, or not something that you have to do every time. But the applications would definitely use those many times.
And so here you can see, of course, it's not yet healthy, but here we will. Now, most probably it has been going through. Yeah, now it's all healthy. But then it's also what it did as part of this component. It's also creating documentation for. So when you define kind of the component, you put some inline documentation. I put a description. So it's automatically creating this page describing what this component is about, what this parameter is about, if there is a default, if it's required, or if it's true. So it's documenting, but also people can discover the different type of components, the different trait I'm speaking about here, and so on and so forth. And this is here a UI for it, but you can also discover that from a CLI. So you are creating your documentation inline into your component, so you don't have two things to maintain. So as you modify it, your documentation is also maintained. Yeah. So this was this demo, and then so the feedback we got from. Yeah, so I will just quickly go on that. I will not even go to the end. The feedback we got from the application developers, they were kind of saying, yeah, it's nice, but some of it, like the crossplane aspect of it, or the queue, is a little bit too platformish. We are used to kind of more better language, and say, okay, what about we create kind of more agentic kind of framework on top of it? So you just describe what is a contract you want to implement, you tell which type of component it is, and then it's generating also manifest for that. So then they have really something to start with. I will not go to the end of all of that. It will be, again, posted. But really just to finish on top of that, again, before it was ticket ops, a lot of things that were required that needed to be done, they need to wait, and so on and so forth. And then it became more self-service. Some lesson learned, so I shared some of it is, of course, it's important. The contract is important. The security boundary, so we spoke a little bit initially about the fact that it was just either you can be an admin at the namespace level or an admin at the cluster level. So what we did is, to do a middle ground, we implemented some policies to create a role that is having kind of some middle ground access. So the component contributor in dev has kind of a lot of access, but in prod has read-only access and different kind of rules like that. So this is how we kind of enable that.
Yeah.
And we are.
Yeah, I know we may not have time for a lot. Just full disclosure, we are also one of the maintainers for KubeVela. There is a booth at the project pavilion for KubeVela. We're happy to talk to you guys about our experiences so that you guys don't have to go through the same all over again. Happy to discuss architecture, or if any of you guys are interested in contributing back into open source, into KubeVela, we'll be happy to support and aid that forward.
So this presentation is attached to the agenda. You can download it, and you will get the PDF, all of that. You can take picture, but you can have the PDF view of it.
Cool. Do we have time for questions, or? Zero? All right. So you can catch us outside for any questions you have.